Hello everyone, welcome to this lecture video on the process scheduling synchronization. In this lecture video, we are going to discuss about the deadlock and what is a deadlock, system model of a deadlock, and what are the characteristics of deadlock, and how we can avoid the deadlock avoidance. So here in the introduction part, we are going to discuss system model, what are the deadlock characterization and methods for handling deadlocks, deadlock prevention, deadlock avoidance, and deadlock detection, recovery from deadlocks. Here, before going to this lecture, we have to know process and threads. We all know what is process. It is a the things under whatever the process sent to the CPU under the execution, the program under execution we call as process. So process requires resources if the resources are not available at that time. So coming to a deadlock, we can simply understand, for example, there are two trains coming in the same track. There is no space for sending the train. So it happens deadlock without have the problem in alerting the tracks for each train. So only one train can travel in the particular track, so that causes deadlock. So similarly, same like that kind of things in the deadlock, a process requests from resources. If resources are not available at that time, the process enter a waiting state. So sometimes a waiting process is never again able to change state because the resources it has requests held by other waiting process. This situation is called as deadlock. So sometimes a waiting process never again able to change their state to other state, waiting state to request state or steady state, ready state. So it can't able to allocate the resource for the particular process because it held up by other waiting process. So this kind of situation is called as deadlock. So system model, for example, system consists of resources. Resource types will be R1, R2, R3 up to RM. So the CPU cycles we already discussed what is CPU cycles, and memory spaces and other input await devices. So each resource types RA has WA instance. Each process utilizes resources as follows as request and use and release. So here we can have the request, use and release. Will be able to have the different kinds of process to utilize a resources. So here a process must request a resource before using it in a release things. So a process may request many resources. Particular process request many resources to request to carry out a designated task. So the particular process will requesting needed resources to carry their process to complete their task. So obviously the number of resources requested may not exceed the total number of resources available in the system. In the other words, a process cannot request 3 printers if the system has only 2. In this example, we can able to see how for example, the 3 printers, there are only 2 printers connected to the system. A process cannot request 3 printers if the system has only 2. So these kind of things causes the deadlock. So necessary condition, deadlock characteristics is the first thing is a mutual exclusion. Only one process at a time can use your resources. There is a mutual exclusion. A deadlock can arise if 4 conditions hold simultaneously. Only deadlock can be deadlock can be happens if the 4 conditions hold simultaneously: mutual exclusion and hold and wait. A process holding at least one resource if waiting to acquire additional resources held by other process. So hold and wait causes deadlock. No preemption. A resource can be released only voluntarily by the process holding it after the process has completed its task. Then circular wait. There exists a set P1, P2, P of waiting process, such as P is waiting for resources that is held by P waiting for held by the P. So waiting for the resources held by the P1, P2 or resources that is held by the other process. So mutual exclusion, hold and wait, and no preemption and circular wait. This causes deadlock necessary conditions: mutual exclusion, hold and wait, and no preemption and circular wait. So this resource allocation have the set of variables request stage and assigned stage. So resource allocation graph, for example, the process have a single process a resource type with 4 instances. Prerequisite instance of R, P of R, P holding instance of R. So P of holding instance of R. So for in this picture we can have the example of resource allocation graph. We can see this lecture in the next lecture video of the how the resource allocation happening in the deadlock. Thanks for watching. Thank you all.